Hello everyone, here are your narrated notes for section 1-3. These are really quite small, so I will post them just as documents as well in case you just need to look at them without the narration just to get a little bit closer view. Basically, this is all just some vocabulary that we're going to be using. First word, coordinate, just the real number that corresponds to a point on the line. The distance between 2 points when you just have a number line is the absolute value of the difference of their coordinates. So you're given a number line, you just take the two numbers marked on the line, subtract, and take the absolute value. The reason why you're taking the absolute value is because length always has to be positive. You would never have a negative length. Probably one of the most important parts of this section is the segment addition postulate. We're going to use that a lot. It basically states, again, if 3 points on a segment are collinear and point B is somewhere between points A and C, then AB plus BC equals AC. I think the simpler way to think about that is just little piece plus little piece equals big piece. If you have a segment and it's in sections, obviously all of the sections add up to the total. That's the key idea with the segment addition postulate. The word congruent comes into play a lot. We're just talking about things that are the same size. So with segments, congruent segments have the same length. Midpoint is also very important in this section. It is pretty much exactly what it sounds like. The midpoint is a point exactly in the middle of the segment, so it creates two equal pieces. Very important idea because that's going to help you set up equations when you're working through some of these problems. A segment bisector basically does the exact same thing, except a midpoint is just a point. A segment bisector is usually some other segment or a line or a ray or something like that, but it just creates two equal pieces as well. So this is the time to start setting in your mind the idea that if you see words like midpoint and bisector, you should start to think automatically two equal pieces, because again, that's going to help you set up your equations. So for a couple of examples here, I have two different examples on this page. The figure looks the same, but we'll find out that looks are not everything. So for the first problem, I have line, points on the line, J, Q, and Z, and I have JQ marked with 4x minus 20 and QZ marked with 2x plus 30. In this problem, I'm given that JZ equals 100. So I'm given that the whole thing is worth 100, and that's the only information that I'm given. So even though Q looks like it might be in the middle, since I'm given no markings on this figure, or I'm not given that I have a midpoint, I can't make that assumption no matter what it looks like. Since I'm given a total though, I'm going to be using the segment addition postulate. So I know, no matter what, that JQ plus QZ equals JZ. That's the geometry. Once you set up the geometry, now it's all algebra. Here's my relationship. I just substituted in the expressions that I had for JQ and QZ and set it equal to JZ, which I knew was 100. Worked through it algebraically and ended up with x equals 15. So if I'm supposed to calculate the length of JQ and QZ, well again, JQ was 4x minus 20. I just substitute. When I work through the algebra, I get 40. And then I do the same thing over here. I'm substituting in my value, working through it, and getting 60. And again, my check is, since I was given that JZ equals 100, those two separate pieces should add up to 100, and they do. So this problem is good. Again, since I was given a total, I use the segment addition postulate because I know no matter what, that little piece plus little piece equals the big piece. On the second problem, the figure itself looks exactly the same, except that I was given different information. In this one, I'm given that Q is the midpoint of JZ. So I did these little markings here, these tick marks or hash marks, whatever you want to call them. Those indicate that I have two congruent pieces, and I was allowed to mark that because I was given the midpoint. So since I'm given that information, I know that JQ equals QZ. So I'm still going to solve with algebra, but the equation that I set up was a little bit different. I didn't have a total, so I couldn't use the segment addition postulate because I would not have known what the total was. I was given the midpoint. Again, here's my geometric relationship, and here's my algebra that goes with it. I just substituted in 4x minus 20 equals 2x plus 30. Worked through it and got x equals 25. So if I'm going to calculate the length of JQ and QZ, again, it's all about substitution. Once I substitute that in, I got JQ equals 80. Knowing that QZ is supposed to be the same, I could just say QZ is 80, but I like to double check my work anytime I can, so I'm still going to substitute in, just to be sure that when I work it out, I actually do get 80. If I ever had an occasion where I substituted it into those two expressions and I did not get the same answer, something has probably gone wrong somewhere. So the important thing to take away from this page is to really assess the kind of information you were given before you dive in. If you're given a total, you're probably using the segment addition postulate. If you're given a midpoint, you're setting two things equal to each other because you know you have two equal pieces. Last example is still these same ideas, similar ideas, just on a little bit more complex figure. So I did all this work ahead of time, but I'll try to go through it step by step how I actually did it. So this was my original figure, and these were actually already marked. I did not mark those. So when I was given this figure, I was given these 5 points on this line. Everything was marked with an expression, and it was marked that this piece was congruent to this piece. I have to solve for x, solve for y, and then figure out how long the entire segment is, dy. So I started by solving for x. Again, I don't necessarily have to do that first just because it says number 1, but that's where I chose to start. So I had these markings. I know that they're congruent. It's good because they were both marked with an x. As you know, you can't solve one equation that has two different variables, but since both of those are x, I was able to just set up this equation, 7x minus 57 equals 3x minus 13. Again, because they're congruent, I'm setting the two expressions equal to each other. I work my way through it and I get x equals 11. Now on to number 2, AS equals 77. Well, I know that AS is 77. Again, even though I looks like it's in the middle, I wasn't given that I is a midpoint and I was not given any markings. So no matter how much it looks like I is in the middle, I can't approach the problem as though I is the midpoint. But since I have a total, I can use the segment addition postulate because I know that AI plus IS is going to equal AS. So again, I just substituted everything I have. The expressions that I had labeled on the figure equals the total that I was given. Work through it and I get y equals 9. For figuring out how long dy actually is, well, I'm just going to work to get some actual numbers to just add together. So if I look at this figure and everything that I've kind of done so far, I know that dA plus AS plus SY equals the whole thing dy. That's how I thought about it first. I took my segment dA, I substituted in my value for x, worked my way through it, and got dA to be 20. I did the same thing over here with SY. Took my x value, substituted in, worked through it, and also got 20, which I should have since they were congruent. So when I came down here to substitute in, I just substituted in 20 plus the 77 I was given up here, plus the 20 I figured out there, and added them all together and got dy to be 117. So to sum up, just look at the information that you're given. If you're given a total, you're probably using the segment addition postulate because no matter what, you know that little piece plus little piece equals big piece. If you are given midpoint or bisector, you are going to set two expressions equal to each other because those two words, midpoint and bisector, indicate two equal pieces. So that's it, and I'll see you in section 1-4.